Hello, we are live. We are back with another round of CockroachDB office hours. My name is Lisa Marie Namphy. I am the head of the developer relations team here at Cockroach Labs, and I am joined today by two of our amazing architects. So Alistair and Bob, I'll let you introduce yourselves. Why don't we start with Bob?
Hey, good morning, good afternoon, everybody. As Lisa said, my name is Bob Ferris. I am enterprise architect here at Cockroach Labs and enjoy working with customers on our distributed database platform to make them successful and to unleash the power of cloud-native database platforms. So super happy to be here today and look forward to engaging with all the questions that come through. I'm based up here in northern New England, up in Vermont. I've got, I hate to date myself, but I've got 25 years plus of experience working on different database platforms. So from DB2 to SQL Server up through NoSQL databases like Cassandra, and excited about Cockroach Labs and what we can do for our customers. So, yeah.
All righty. Thank you. And Alistair?
Similar. I spent 20 years making Oracle work in a production environment, and that was good training ground for what I'm doing now, which is similar to what Bob does. I make our customers successful with CockroachDB. That's my day job. My hobby is programming. I'm a bit of a Python fan. I love to play with databases and database technologies. So that's where the developer bit comes out in me, and I've always retained the enthusiasm because it's not my day job. I just develop when I want to, and I want to play with things. So it's a bit of a passion of mine, but I'm not the greatest developer in the world.
Who is the greatest developer in the world? I don't know if anybody can actually hold that title, or if there's any competition for it, and the judging would be totally rigged. So we don't even need to go there. But as I said, I'm Lisa. I also have a long career in databases. Interesting that you mentioned Oracle. I pretty much started my career there. Not going to tell you when, also dating myself. But many years ago, worked at Oracle for a good long time, and actually started the first developer user group at Oracle many, many years ago. So when I was working in the tools group. So that was, and then I got into OLAP servers, and I worked at Hyperion, and we got into multidimensional databases, and then I got into complex event processors. So I have had this long career with data as well, and analytics, and then got into organizing developers. So I'm also, like a hacker in my nights and weekends, but not in my job. In my job, it's corralling developers and communities and building and architecting mostly open source communities. So that's how I came around to this career. So so for audience, please type your questions in, and we will get to as many of them as we can. We didn't get to them all last time, so we actually have a few that we can cover. And Alistair and Bob, please think about if there's a topic from last week that you want to make sure we get to this week. And if I don't see it written, then go ahead and just jump in, or a good discussion point. And I think we are going to have some time to show some demos. So if I don't see too many questions, we'll just break into a demo here and there. But again, these are the database office hours. This is the Ask Me Anything session. Ask us anything, ask us everything. So AMAs, I guess, could be AUEs, if that works out. So do we want to start out with because I know last time you talked about the basics of Cockroach Cloud Free Tier, and you were going to show a demo. Do you want to start out by talking about that, and if we don't get too many questions, you can break into a demo?
Yeah, I think we just didn't have a lot of time to cover it last week, so it would be good just to step through it a little bit more slowly. And I know we made the point, or we laboured the point, that it's very quick to create a cluster, but we didn't maybe go on and sort of look at how to connect to that cluster and how to do things with it. So let's, I'm going to share my screen, and we'll have a look. There we go. That always looks funny if you do that. Right. Okay. So here's my Cockroach Cloud dashboard. So I've got a couple of clusters that I've already created. These are all free tier clusters in this section here. I love the names. I love the way they get named, an adjective and an animal. So jaunty fish and unripe hyena. I've got pesky rat actually in another environment, which is a really good name. So what the great thing about Cockroach Cloud free tier, well, when you try and create a cluster, you're given two options. So it's either free or it's paid. So what we're concentrating on is the free one here. We can have a look a bit later if anybody's interested in the paid one, which has got a lot more kind of options as to where you can deploy things. So we can choose, and initially we can choose our cloud provider. So we can choose, okay, let's use AWS. Yeah, I could choose AWS. I could choose the one nearest to me, the region nearest to me in AWS. Now, when I was quite an early adopter of this free tier. And I thought it was great because you can sign up. You don't need to give a credit card or a debit card. There's no time limit. Just once you've created your cluster, it can you can keep it for as long as you like.
So let's clarify one thing, because this question came up in our community chat. So you don't actually need an Amazon account or a Google account. You just choose which cloud you want to run this on, and you're not paying for it.
That's right. Yeah. So when I first signed up, this was before I even joined Cockroach, there were very limited options. So there'd only be a single region for each cloud provider, and that was a US region, which meant that it was quite a long way for when I connected from my laptop in the UK all the way over to the States. It was quite a round trip time. But now you can see they're scattered. There are options scattered around the globe, and the same for Google Cloud. So I've got a European option I can choose now, a US option, and a kind of a APAC option here as well. So you can get a cluster that is reasonably close to where you are. We could do it. Doesn't, and again, you don't need to know anything about Google Cloud. You don't need to know anything about AWS. This is all just if your application happened to live in these clouds in a region close to here, then you would want to choose a region here that was very close to where your application was, to kind of reduce the latency between your application and your database. So we can go Google Cloud. It really doesn't matter. We've got Jovial Sheep this time. You can change that, but why would you want to? It's a good name, isn't it? Right. And just create your free cluster. Now, because there's no real infrastructure being provisioned here, these are just slices on infrastructure that is already provisioned. There is no need to go off and provision VMs or anything in the cloud. That's it. It's done now. And now it's giving me the details of how I can connect to this. So if we just go down here, it's just giving me the way I can connect to it. So I can copy this, and I can paste this into, and I'm a Windows user, which I'm a bit unusual in Cockroach Labs, that I'm a Windows user. There's not many of us. I use PowerShell. I'm going to simplify this a little bit.
I didn't know that, Alistair. Man, that opens you up for some comments, but we'll stick that for now. Didn't want to comment, yeah, like Alistair said, I mean, that cluster name is completely configurable, so you don't need to be stuck with what we default it to. And the other thing that you'll notice that Alistair didn't have to put in any credit card. This is completely free for life, so we're not gonna ping you later to undo credit card charges or anything like that. This is completely free and available to anybody that wants to go out there and experiment with Cockroach Cloud and test out their applications against a truly distributed database.
So who is paying for all of the Amazon Cloud credits? How does that get paid for?
These are slices, as I say, off infrastructure that we've already provisioned. So we give you a kind of virtual slice, so that keeps the costs down, so that we can offer this out to as many people who want to adopt it, without the cost spiraling of having to fire up VMs for every single user. If you want a VM, a series of VMs to yourself, and get dedicated resource because you've got a production workload and you want to guarantee that you're going to get the performance, then we can do that. That's going to cost, though. You're going to have to pay for that. This is the free tier option. and you get a reasonable amount of space and up to 1 vCPU's worth of kind of power, CPU power, to do kind of experiment and do what you want to try your stuff out.
Yeah. I mean, I think we give you up to 5 gigs of storage for free and the 1 vCPU. So I thought a question had come in, what the limits of the free tier are. So that's like Alistair was alluding to, it's not going to be driving any real heavy production workloads, but certainly great for getting started and testing out your applications.
And here, instantly, I've managed to embarrass myself and not connect. Now, the reason this would have connected to a normal CockroachDB, but because this is a virtual slice, I need that cluster name. I need that specific cluster name that's been created for me here, which in this case is Jovial Sheep. So just need to include that. I can either put the minus cluster name at the end, but it's easier just to stick it in front of the database name. That's the easy way to get started. So Jovial Sheep dot default DB is our default database name. Invalid cluster name Jovial Sheep. There's always an extra bit. There's always not just Jovial Sheep. There's always a little extra bit. The number 1365-1365. There we go. And now I'm connected to CockroachDB. And we can do whatever we want to do now in terms of it's a relational database. We can do the standard kind of things. We can create a table. I always end up creating a table called test tab, and then I always get the letters in the wrong way. And this is just standard kind of syntax. We are Postgres wire compatible, which means that anything that can connect to Postgres can connect to Cockroach. We are in the main Postgres SQL compatible, but we're not Postgres. We are not a fork of Postgres. We haven't taken Postgres and made it into Cockroach. We have written Cockroach from the ground up. Now this does mean that occasionally some things which work in Postgres won't work in CockroachDB. It's not 100% compatible, but it is very, very, very compatible, and most of the things you could do in Postgres you could do in Cockroach. So I could just create let's create a ID, a UUID. I'm going to make that the primary key. I'm going to give it another column, which is, I don't know, a name, and I'm going to call that. Now this is a varchar. From my Oracle days. Postgres is quite Oracle compatible for some of its data types, and we accept the Postgres data types as well, and also might give it an age, integer, something like that. I've created a table, and now it takes all those kind of Postgres shortcuts like \d describes. If you just do it, it just describes what the tables you've got currently in your local database that you're connected to. Remember, I'm in default DB, which is our default database. And we can do describe of the actual table that I've created. And there we go. There's the columns. Now, we accepted the Postgres syntax there, the varchar and the integer. But under the covers, we converted it to we do accept varchar actually, but int gets converted to an integer, gets converted to an int8. So most of the Postgres data types we'll support. Sometimes we convert them under the covers to a Cockroach native type. So we might do a show create. Where are we? Show create. Test tab. There, when we generate, this is the SQL that you could generate. If you wanted to put this into another environment, there's an easy way to do this. If you want to get rid of the bit at the front here, you can put square brackets around any of these show commands, and you can do select, in this case, create statement from there, and I can get rid of that. So I can just cut and paste it, put it in a script, or in a Liquibase script, or something like that. And that's available to run into another environment. You can also create indexes as well, just like any other relational database. So I could do a create index. You don't have to name them; they will get named automatically. So I could create index on test tab, brackets name.
We have a question as well, just for clarification. UUID?
A UUID, yes.
Yeah. So, go ahead, Alistair.
No, go on.
Yeah. So a UUID is just a universally unique ID. It's randomly generated by the database and we use them a lot for just to avoid and make an easy use for a primary key on a table, so that we guarantee uniqueness across tables. So it's just a data function within the database and within a lot of databases. I know that people familiar with Oracle, they use sequences a lot to generate their primary keys. We try and stay away from that type of primary key generation within Cockroach for a couple of reasons, and namely because of, I don't want to get too deep, but the way we store underlying our key value store, we try and avoid actual sequential primary keys. Not that we can't do it, but that's why Alistair's going with the UUID. That's one of our better practices when you're designing database tables within CockroachDB.
And I could have provided that UUID, so I could have generated it in my application. Some developers like to do that, or some standards say that you should do that, or you can get it generated within the database. So this is a function within Cockroach database, Cockroach cluster, which is called genRandomUUID. Just generates, as it says, a random UUID. But I could also have assigned this as a default value to that ID column, so that I don't even need to insert it. I don't even need to mention it. I could have just said insert into test tab, name and age, Alistair 21. Of course I'm 21. But I wouldn't even need to have mentioned it then, or put the function in. It would have automatically generated a default value. And you could do the same for example, for sort of like an date inserted. So I could do, I'll just show you the use of a default value there. So alter table, I can easily add another column. So test tab, add column. Word column's optional. Inserted date, say, and we'll make that a timestamp. And the default is another function which is called now. There we go. So we then describe, it won't affect, because it's a default value, it won't affect existing rows, it'll only affect new rows. So we'll just have a look at that one now. I'll describe the table now, and we can see that we have an inserted date, timestamp, and it's a default value there, which is now converted to a timestamp. That's how we say we're going to cast to a particular type. So the output of that now function will be cast to a timestamp, and then if I do another insert, let's be lazy and do that. So how old is Bob? I don't know. He's quite old, isn't he? He's about 65, isn't he?
Yeah. Killed me.
Select star from test tab. Now,
not that close to retirement.
There we go. So
we'll get him.
So actually, it did give my it updated my row, because I didn't have this row, this column didn't exist when I inserted my row. So it's obviously put a date in when that column was added, and then as the other rows get added, they get the date automatically added. And so we could do the same default function to create an automatic UUID.
Yeah. I mean, that default behavior is kind of interesting. I mean, when you do default a value, it will get updated when it's applied across the table to existing records, and taking this one step further, that's interesting and valuable to note when you're doing things like change data capture and change feeds within Cockroach. When you're exporting data automatically out of the cluster, it's good to understand that default behavior when you're making schema changes against your table.
Okay, so just so we can recap here and tell people a little bit about what we just did. So you created a free tier cluster totally free. You chose your cloud. You then created some tables. I think the screen is very small. I can't really see, but hopefully everybody else can see. And then what was the last thing you did, Alistair?
Then we added a column and we created a default value for that column.
Okay, and you did all of that in like 10 minutes. So showing how easy it is to use Cockroach Cloud and Cockroach Cloud free. And we had a question also, just so we can recap. What's the size? What are the limits for Cockroach Cloud? Like what's the size of the database, or is it based on queries, or what are the restrictions?
For free tier, it's the amount of storage you can have is 5 gigabytes, and you have one vCPU of sort of power, processing power. But once you go to the Cockroach Cloud paid option, then the world is your oyster. Basically, you can keep adding nodes and adding resources and adding more powerful machines, dedicated machines. So you can go much, much larger.
Okay. So we showed how to do this. Let's talk a little bit for a minute about the why. What would drive developers or companies to a fully managed database as a service like Cockroach Cloud?
Yeah, I mean, I think that's the question of the day. The market is evolving and technology is moving forward, rapidly. And whether you're looking at Gartner or the white papers out there or any other market research, the market is going as a service. So database as a service, software as a service, and away from, that question really has two answers in my book. I mean, companies are moving toward the cloud and moving toward database as a service for total cost of ownership, for TCO gains. So they don't want to be in the business of managing their own servers. They don't want their SREs and their database developers to be doing the mundane tasks of upgrading this or upgrading that. So that's where Cockroach Cloud really fits in. So you go ahead and configure what you need in a cloud database as far as compute power and storage size, and then you turn it loose, and our SREs, our site reliability engineers, they monitor it. They if things come up, they're the ones that get paged. They're the ones that fix things. So it's an ease of use, and it's a total cost of ownership. It frees up your people to do more valuable tasks to your business. So, Cockroach Cloud really is adding business value to your organization so that they can, solve other problems and move on to other things. So that's kind of the way I look at it from the company side, and from the developer side. It's really about ease of use and bringing a positive experience to the developer. We just saw Alistair spin up a Cockroach Cloud cluster in absolutely no time. So if a developer needs to unit test something or figure something out or test something different, they don't need to go to their internal infrastructure team. They don't need to go to their DBAs to configure a database or configure the hardware necessary to run to run those kind of tests. They're in control of it. It's easy to use. It's a simple user experience, and so again, it's all about developer productivity from that side of the equation. So to me, that's what Cockroach Cloud brings to organizations and developers.
And then at completely the other end of the scale, I'm just stepping through here of creating a 3-node cluster, 18 nodes, much more. You talked about hardware and how much disk we could have. So here we're now having sort of a total of 18 nodes, each with 900 gigabytes of disk on, and we can go much higher than that if we want to. And this is all just through this screen. This will take a little bit longer than a Cockroach free tier cluster to create. This will take about half an hour. But you imagine it amazes me how we could do this. I mean, how long would it take to get 6 Cockroach nodes all working in Kubernetes, which is what we use under the covers to run Cockroach Cloud, running in 3 different cloud regions, them all talking to each other, because in Cockroach every node needs to talk to every other node. That's a requirement. Having all that networking sorted out, being able to quickly choose the size of the machines. And again, I could say, well, actually, I didn't want Google, I wanted AWS, and I can change, and I've still got all the options here. I don't need any cloud-specific knowledge. I just need to pick the cloud that's most suitable for my use case. And then I click all the various bits and pieces. In this case, it's offering me to put a trial code in, and how much is payable, hourly cost, all that kind of stuff. Obviously, that's not it's not as simple as the free tier in terms of payment, but in terms of infrastructure, that it's absolutely amazing what we can do just at the click of a button.
And it looks like we have a question from Haratuk. Are these Cockroach Cloud instances managed and patched automatically?
Yeah, I mean that's a great question. So kind of going back to the value prop. I mean, we do. Cockroach Cloud operates on our Kubernetes planes, so they're all managed automatically, and they are patched automatically. We upgrade the CockroachDB version when that comes out. We release, with CockroachDB, we generally release 2 major releases per year, so we will upgrade your databases for you, and then within 3 days, we'll finalize that upgrade. So if you see any issues or whatever, you do have the option to roll back major upgrades within 3 days. The dot releases, for bug fixes and all that are patched automatically. So that's a no operation for your team. You just get to sit back and let Cockroach run and not have to worry about it. And on the kind of on the managed side, we have internal alerting and monitoring set up. So we do break it down. There's some things that we can configure to alert customers on, and then there's some issues that may crop up that would only be alerting our SRE team. So fully managed, fully monitored. So you don't have to spend nights worrying about what's going on with your Cockroach database.
Excellent. Okay. I think we had also a question from Rain. If I have a MySQL background, what's the learning curve for switching to CockroachDB? And are there resources already available to help make that easier?
Sure. I mean, I think Alistair alluded to that. We are Postgres Boyer compatible, which is, SQL ANSI. So if you have a MySQL background, I mean, hopefully everything that you saw Alistair do, from create table to add index to alter table to inserting data, if you have any kind of SQL background, that it's a very small step to get to CockroachDB. It's familiar and intuitive and easy. So we do have a lot of different resources available. I'd probably point out getting started with Cockroach University, which is our online training portal. It's absolutely free to anybody. You just go and sign up. So drop it right into Cockroach University and start learning some of the specifics and about CockroachDB. But and then from there, there's all kinds of papers. I would be remiss if I didn't point out that our online documentation, I think, is world class. So a lot of questions and how-tos and getting started is available straight on our docs site. So it's pretty easy to make the switch. The one thing that coming from a MySQL background that you hopefully will appreciate is what a distributed system, what a distributed database like Cockroach provides. Always on, always available. You can't kill it. The survivability of the database and the availability of it to your application is something that you struggle with legacy databases like Oracle and MySQL. If you have to manually shard things with MySQL and things like that. So there are things to learn and understand with a distributed system, but as far as developing it and getting going with CockroachDB, it's an easy step to take. So
you and Alistair both mentioned being wire compatible with Postgres. I want to drill down in that a little bit more because we get asked this question a lot, especially from people that are new but that are very familiar with Postgres. So does that mean that any application written in Postgres is going to just work against CockroachDB?
Not quite, no. I mean, my first experience of Cockroach Cloud was taking an existing application and making it work with, it was working with Postgres, and I wanted to make it work with Cockroach. It didn't work out of the box. There were one or two things I needed to change. Schemas. Now, I've just created a new database here called UDB. I can create schemas here. So I could create a schema called sales, for example. That didn't work when I first started using Cockroach Cloud, but it does work now. Now we can have user-defined schemas. So as time goes on, because we take the SQL interface of Postgres, we recognize it, and we accept most Postgres commands. Because we're written from the ground up, there are one or two things that we haven't implemented, most notably triggers and stored procedures. That is something you will not see anytime soon in Cockroach. So if your application depends on triggers or stored procedures or anything like that, code within the database, then that is not going to be implemented, or not going to be easily implemented in Cockroach. You would need to do that in part of the application. But there are more and more things coming in. As I say, more and more stuff comes in as we go. There are some things that are not implemented. So if I try and if I go back to my other database here and describe my test tab, for example, say the XML data type, we do not. If I try and add a column with XML. So I'm going to add a new column called XML data of type XML. Now, if I just put any old rubbish in there, if I put rubbish in there, we would know that is not a data type of any description, not recognized by any database, or probably. But XML, we do recognize its Postgres syntax, because then we get this error. And sometimes we get a link here to an issue, GitHub issue, publicly available, that would discuss when that issue, if and when that feature is now going to be implemented. In this case, I don't think we do, but in a lot of cases, you do get a link here to find out when that particular piece of functionality is going to be implemented. So we recognize its Postgres syntax, but because we're written from the ground up, we don't recognize it instantly. And there will be a few things like that, a few little things that, having tested your application against Cockroach, they won't work exactly as they did against Postgres. So you can't just assume it's all going to work perfectly.
Okay. Thank you for that. We have another question. I don't know if it's going to be easier to talk about this or maybe to show it if you want to demo, but someone was asking about how you monitor the database in Cockroach Cloud and how you can measure performance.
Right. It's not very easy in free tier, but then you're not going to get in too much trouble in free tier with the kind of resources you've got. But if you're in Cockroach Cloud, then you can use the DB console. If you're using a dedicated Cockroach Cloud cluster, you can go to the DB console, which is our sort of GUI control, mainly monitoring sort of application. There are lots and lots of different metrics that you can view over time. So here's hardware, for example, on this cluster, and it'll show CPU percentage by node. So I've obviously got, this is a 9-node cluster. This is split over 3 regions. And I can view the CPU usage, the memory usage, and disk writes, disk reads, all that kind of stuff. This is all available interactively. And you can go over various time periods to view that kind of information. You can look through this kind of statements that are running and see how they're performing, what sort of time they're taking, how much memory they're taking, how much of the total time they are consuming of the database resources, that kind of thing. transactions in the same way. Transactions will show statements grouped together. So there's lots of functionality. Latency as well. So in this case, because it's a 3-region cluster, we see very different latencies between the various nodes of the cluster. Locally, they're just a millisecond or so talking to each other, but obviously between regions, this is split across 3 continents. So we've got that is Tokyo, I believe, Google's Tokyo data center. Europe West 2 is London, and this is Sao Paulo in Brazil. So obviously you get varying latency, so you can view what kind of latency you're getting, and if you're getting much worse latency than this, there's maybe a network problem or something like that.
And Rain is asking, can you set up alerts based on performance so that notifies you?
Yeah, I mean, there's alerts built into our Kubernetes backplane that operates Cockroach Cloud. So, like we alert when CPU reaches a certain threshold. If disk usage is approaching 80%, we'll get an alert to figure out if we need to add more disk or purge things. So it is built into the backend, the monitoring, and then using Alert Manager to alert on specific constraints. And if you do have specific reporting requests, we can look at customizing that as well. So absolutely, it's a fully managed offering. So alerting is important for anything. If you're hotspotting a node or you have some issue with the cloud provider, we'll be alerted, and hopefully the Cockroach Cloud cluster has been configured to meet the survivability goals that you have. So we'll take care of that. But just to build on what Alistair was saying with the database admin UI, I think it's a great feature. I mean, even though it's a fully managed service, you can go in there, you can see what's going on with your database, similar as if it were self-hosted, and you can go in and see what potentially, if you wrote some bad SQL, what's taking so long. We give you the diagnostics to be able to troubleshoot those kind of things and see what's going on with different jobs and statements and transactions within your database. So I think that's an important consideration when looking at managed services is how you can tell you're giving up a certain amount of control for ease of use and management purposes, but you still want to be able to see what's going on and what's happening.
Okay, we have, thank you. We have another question. This one's from Matthew. Does the contention column refer to resource contention?
Yes, well, particularly not necessarily resource contention, more likely to be contention between different processes trying to access the same data. So obviously this is a strongly consistent database, ACID compliant relational database. If 2 processes try and access the same piece of data, then one will block. They won't both be able to make that modification at the same time. So that's mainly where contention comes from.
Yeah, I mean, we fall on the, when you think about the CAP theorem, we fall on the consistency and surviving partitioned network partitions. So, that's how we guarantee ACID compliant transactions, and because to do that in distributed environment safely, we use that serializable isolation level. So potentially you could see some contention, and this is an easy way to spot that and look at your code and figure out what's going on.
Yeah, so you can see in this particular case, it's an update on this is an internal table, system.jobs, and jobs is where we store all the kind of things that are going on internally in the cluster, like particularly backups, but also other jobs, schema changes, change feeds, all sorts of internal activities are tracked via jobs. Alter table there, you can see adding a column to a table there was tracked as a job, and that the contention obviously came from multiple processes trying to update the same piece of data at the same time, or the same area of the database.
Okay, so what else super cool feature you want to show us? Something like, looks like Dan is asking for schema change.
We want schema change, yeah?
We want you to show off all the cool features.
Right,
all the
okay.
time we have.
Well, I mean, we can certainly, we showed adding columns. We can drop columns as well. There's a bit of a safety mechanism on that. So let's go
also,
back.
Alistair, can we ask you to increase the size of your command line? It's just a little bit small for us to see what you're typing.
Right, okay. Probably. Didn't think about that before. Here we go.
Sorry, I know I should have asked before. I didn't realize it was going to be so small. But I'm not the only one who can't see it. Yeah.
So schema changes. What could we do here? We could drop a column. Yes, we could do that. And all this is done online. There is no need to take anything. So all that index creation we did earlier, that was all done online. There could have been lots of activity going against my table at that point. I wouldn't have had to have stopped any application processes to create indexes, to drop indexes, to add the column. We created that new column with the new default and populated all the existing rows. All of that is done with the jobs mechanism, as we showed there, in the background. And you can reads and writes to the table are carrying on, inserts, updates, deletes, selects are carrying on as normal when any of these schema changes are happening. So we could change what could we change there? We could change the timestamp to a timestamp TZ, I suppose. We could do alter and this table test tab. Now I'm going to now you see, now we're going to use the docs, because I'm going to struggle with the syntax. You see, this is where the docs, we talked about the docs being really, really useful. So I'll go to the docs and I would put in alter table, for example. Alter table statement, and I get these nice railroad diagrams. What do we want to do? Alter a column. So we click on that. Then we get the railroad diagram. So I like these because you can follow it through. Alter table, right, if it exists, yeah. Table name, alter column. Not modify. I thought it was alter. I thought it was modify it, but it's not. It's alter column. Set default. We could set it. We give it a default value. We could set it not null or null type. We can change the data type. Here we go. So data type, type name. Put it to a timestamp. EZ. I haven't put the column name, have I? Let's put the age. Not age. Inserted date. Yeah, I missed the set. Look, I missed that. I just saw the data type and missed the set.
Live demoing, folks. This is turning into a watch me work session. This is awesome.
And I can't spell timestamp TZ either. I can't spell timestamp. Just to show that it's real. And so there. Now we just altered the type of the table. And now if I just display the table now, we can see that we've changed the data type. We might decide that this timestamp here is more relevant to our use case, and we can get it changed automatically, and the it will cast it as we need to the right times, to the right kind of data. So that's all done online, no need to. And I said we could drop a column. Let's drop the age column. We don't want to be ageist in this show, do we? So I do know this. I do know the syntax for this. So alter table, test column. I think column might be optional, but I'll put it in anyway. Age. Now this is a Postgres function that we've inherited. This is going to be quite damaging because you will lose data. There is some data in this column, and by dropping this column, we will lose data. We won't be able to recover anymore. So what we'll do is set SQL safe update. So this is taking the guardrails off now and saying, yes, we realize we're going to be doing something dangerous now, and we know what we're doing. So we'll set SQL safe updates to false, and then we'll redo the drop. Now, we've lost that data. We've got no idea how old anybody is now. Select star from test tab, and the age is gone. Now, one of the you talk about cool features. One of the cool features here is, well, actually, I didn't really want to lose that data. I really wanted to know what was in there. What can I do now? Do I could restore a backup? That's a bit clunky. But oh, hang on a minute. Why don't I put as of system time? Right, let's just say -1 minute. -1 means 1 minute ago. Ah, magic. So what's happening here is that under the covers in our key value store, we've retained the original copy of the data that had the age column in it. So it's also not just the original copy of the data, but the metadata that describes this table. We're going back a minute in time, and we're seeing what was there, so we can recover this data just without any kind of restore or any clunky operation by just putting that as a system time clause in there. And that's a really useful feature to be able to go back just a little bit of time. And also we can use this to move us. So we talked about contention earlier. In the way that we have serializable isolation is our isolation model that we use in CockroachDB. It means that readers can block writers and writers can block readers under certain circumstances. But if we take it back a minute into the past and read data, if we were just doing a report for a summary and saying, well, roughly how many of these people, how many people have we got under this age or over that age, or any kind of sort of query where you don't need the data to be right up to the minute, you can put this as of system time in there, and you can query that data totally away from the processes that are currently trying to modify the data. You won't be blocking anybody, nobody will be blocking you, and you'll still get a clean view of the data, but as of a certain time in the past.
Yeah, I think that's one of the absolute genius designs of CockroachDB, that concept of the way we do multi-version concurrency control, because you alluded to it, but under the covers, our storage layer for our key value store is an append-only database that we've written based off of RocksDB called Pebbles. So a delete operation doesn't go and delete a record in place. It just appends what's called a tombstone, and it's a logical delete. And the default configuration for CockroachDB out of the box is to save 25 hours of that MVCC data, so that you can do these type of time travel queries like Alistair just showed you. You'll hear them referred to as follower reads, and they can come in handy in a lot of different use cases. Going back to the question of contention, they won't block new transactions coming into the database. So it's really a fantastic feature. And I've even worked with customers where they've done something terrible, and you can actually, if you have a good backup and restore policy, you can actually restore backups to a point in time based on that MVCC timestamp, and you can save your bacon that way.
Yeah, in fact, exactly the same kind of structures that are underlying this time travel query here of going back 1 minute are what help us to do point in time recovery. So we can have a full backup. You can have it daily or hourly or whatever cadence you like. You can then have a series of incremental backups in between, and they capture this revision, what we call revision history, or that's the option in a backup, that would capture all of the intermediate steps. So we can go down to an absolute timestamp, really clear timestamp, right down to the millisecond or the microsecond or whatever, and say, what did the database look like? What did this table look like? What did this database, what did the cluster look like at this time? Because we're storing all of that revision history. So that's really useful. And there we can see the difference between 1 minute ago and 11 minutes ago shows that we changed the data type of that. Remember, we changed it from a timestamp to a timestamp TZ. So we can see that change in there. If I now go back and do that 1 minute ago, of course, I've now lost that change. That was older than a minute ago when I dropped that column, but I just needed to go back a bit further to see the column that I dropped.
All right, cool stuff. Is there anything else, and we're about to wrap up here, is there anything else that you want to mention that we haven't covered yet, or that you want to recap, or just key points you want to leave the audience with?
Well, I think what I'd like to leave people with is that it's really easy and quick to get started. But once you've got your application working nicely against it, and there are lots of different drivers, there's lots coming up in future sessions. We'll talk about Python, we'll talk about Node.js, probably almost certainly we'll run into Java and Hibernate at some point. And they all work with CockroachDB, and you start off in this free manner and just get going, get up and running really, really quickly. But then you've got these options to produce global clusters very easily at the point of a button, point and click, that will run exactly the same versions of Cockroach in whatever infrastructure you want to, and whatever size of infrastructure you want. Although here you can have a multi sort of Google Cloud cluster or a multi AWS cluster, if by sort of special arrangement we can organize you to have it split across multiple clouds, with some regions in AWS and some regions in Google. That's not available as a point and click, but it is possible, and we do it for some customers. So there's so many options, just starting from this very basic and easy to use free tier.
All right. And Bob, any last thoughts from you?
No, I think Alistair did a good job of covering the getting started and how simple it is. So no, I think hopefully the audience found it useful and appreciated the questions that came in. So
okay, so, and as Alistair mentioned, next week's session is going to be about practical Python, and Rain will be back as your host, and I know they're super excited about that. Python is Rain's love language. I've happened to know that for years. So that'll be a really, really fun show. And I want to let the community know that we want to take your questions. You don't have to wait until the show runs live on the air. You can go into our community forum or Slack, and you can post your questions throughout the week and just let us know these are the topics you'd like us to cover. So this is your show. We're here for the community, and anything that you want to talk about, it's an Ask Us Anything, Ask Us Everything session. But if you queue up, if you want to see a particular demo, just give us a heads up so we can make sure we got that all ready and set up and have all the right people here as well. So thank you very much. Thank you, Bob. Thank you, Alistair. That was so much fun hanging out with you for the last hour. Thanks in the back channels to our producers, Dan, and thanks to all the questions from Rain and Matthew and Hartuk and the rest of the community. So keep us posted on what you want to hear, and we'll be right back here next week at the same time. Thanks, everyone.
Great. Thanks everybody.
Bye.